Welcome to Arduino TinkerCAD simulation series. In this tutorial, you are going to learn about how to interface a photoresistor with the Arduino UNO development board using a TinkerCAD. Let's explore this circuit using a TinkerCAD and AI tools. Head towards tinkercad.com and click on the Create button, then select the circuit option, which will open up a circuit playground in TinkerCAD. Now save the project with proper title like Photoresistor with Arduino and hit enter, which will save the circuit on TinkerCAD platform. It's time to bring components to the playground. To build a circuit for photoresistor interfacing with Arduino, scroll down in components list and bring breadboard small on the playground as shown on the screen. Along with breadboard, bring Arduino UNO R3 on the playground and place it near to breadboard by rotating its orientation. Now bring the photoresistor from the components list and place it on the breadboard as shown on the screen. We also need a normal resistor for this circuit design as we want to create a voltage divider network using these both components. Now we need to create a power supply connection on the breadboard with plot 5 volts and ground pin from Arduino UNO R3. Let us connect the circuit as shown on the screen, which includes connecting plot 5 volts to normal resistor and ground to photoresistor. The middle connection between normal resistor and photoresistor is connected to ADC pin of Arduino UNO to read the analog voltage difference from the voltage divider circuit. Now our circuit is ready. It is time for generating an Arduino code from Perplexity AI with a detailed prompt as shown on the screen. Mention all the important parameters, conditions and requirements with connection details in a prompt to help AI tool to generate most efficient code for our project. Now analyze the code line by line and make sure that all parts are very clear to you. Then copy and paste this code from Perplexity AI to TinkerCAD coding window. Open a serial monitor in TinkerCAD and start the simulation process as depicted on this video. Once you start seeing the sensor data on the serial monitor, then click on the photoresistor and change its intensity by scroll bar on the sensor component. Notice very carefully how ADC value and analog voltage is changing from 344 to 1017 upon scrolling full scale on the photoresistor. This is the exact value which can be further used for making decisions on project implementation level. Out of my curiosity, I'm trying to scale the 344 to YNOW117 ADC value from 0 to YNOW23 as it matches with 10-bit ADC full-scale value The same requirement is given to the Perplexity AI with a detailed prompt as shown on the screen. The resulting updated Arduino code is now ready from Perplexity AI. This one I will copy and replace it in TinkerCAD simulation tool. Now let's simulate the same circuit with updated code for better data mapping and visualization. Now we can see that on this simulation, the lowest position on photoresistor is creating 0 value on the serial monitor, and highest position on the photoresistor is creating 1023 value on the serial monitor. This is how we need to explore and understand components' behavior to match with the real-time project design engineering. If you got any questions and suggestions on our TinkerCAD simulation series playlist, feel free to comment below. I believe you learned something new in this particular tutorial. Consider subscribing to our channel linked frequency and help us to grow in Arduino and TinkerCAD community. See you again in the next video. Until then, tune yourself to make a difference.